Hello everyone, video 2 of module 3. In this video we discuss about how to create a foundation and how to assign a spring stiffness for foundation. To do this, first we need to move down to the basement, and because we are defining foundation we don't need any vertical support, so I select all joints and coming to assign joint restraint and untick all of them and apply. Now I just need to be able to see the joint, so I'm coming to set display option and untick invisible for joints and apply here. Good. So here we don't need it, so keep it as it is. Now I can see all joints here. So I need to use shell element to model the foundation. So first we need to go to define area section, which is here, or define and then section property area sections, and we need to define a foundation. So we assume that we have a 600 millimeter thickness foundation for all walls around and a 700 millimeter thickness foundation for columns and also a lift wall. So I need to define two type of foundations. So what I can do, I can come on 200 the slab and mention add a copy of section, because the foundation is 32 MPa the same. So I can come here and mention found 632 MPa, and then this is 600, so it's up to us what size. So it could be shell thin or shell thick. I think we can choose shell thick because foundation size is not too much, and so here we put 0.6 meter because currently the units are based on meter. It's 0.6, and I don't generally use modifier for foundation. I'll keep it 1 because it's confined in the sole. And just remember, when you decrease the stiffness, you literally decrease the load, and the internal forces on foundation shown for moment or shear are less. So when you put all of them 1, the internal forces would be more. So we can choose a color here, say orange. Okay, so this is 600 foundation. Again, I can come add a copy of section. Now it's easier because they are very similar to what I want. So I can put font, say 732 MPa, and I put here 0.7, and the modifier was edited last time. I'll just double check everything is fine, and we change this color to a little bit darker, maybe this, and we press OK. So I have found 600 and found 732 MPa both. Now we need to draw it. For foundations for the retaining wall, generally foundations are not extended too much out of the wall. Generally sometimes it's right at the edge of the wall, sometimes it's a little bit bigger. So in that case we assume the foundation is 200 millimeter outside of the wall. So wall thickness is 200. So from center of the wall we have 100 to the edge of the wall and 200 out. So we need to be 300 millimeter out. To draw these, I'm coming to draw a special joints, and so I'm just drawing these corners. So for example here I have positive 0.3 and for x and y, Yep, coming. And then here would be negative y, so minus 0.3. Yes, and then coming here. And then this side is both minus 3.3. So here, and then here is y positive and x negative, so 0.3. Okay, now we need to define the joints at the internal side. So we assume, for example, the width of this foundation is roughly 1.2 meter. So what we need to do, we need to define the corners, inside corners, which we have 0.3 out, so we have 0.9 in. So I'm coming here, minus 0.9, minus 0.9, and I put it here. And likewise for this we need to do the same, so coming here, so y is positive 0.9, and then this side, both of them are positive, and here is y negative. Okay, now I want to draw shell element here. So what I can do, I can draw from one side. So I'm coming here, I select foundation 600, then I'm selecting this one and drawing up to here, and then selecting this one, drawing up to here. Try to keep the actually grade axis the same, so I'm repeating the same procedure to ensure I'm not missing anything. So here I need to start from this corner of shell. Let me zoom in a little bit. So from this corner to this corner, and then from this corner to this corner. Okay, so those are foundation. We need to, of course, we need to divide it, but we leave it by now and we move on for the rest. Now I want to draw the foundation for this wall. I make it a little bit wider, say for example 1.6 and 600 millimeter each side extended. So I'm coming to draw a special joint again, and I just need to draw two corners, opposite corners, to draw the shell. I don't need all four corners. So I'm coming here and mention this is 0.8 and here is 0.6. So this is 1 point, the other point is minus 0.8 and minus 0.6. So I can easily come and draw my shell element here. And then I need to draw foundation for the columns. We assume, for example, very roughly say 2 meters by 2 meters. So I'm coming here again, draw a special joint and put it 1 and 1 and 1 here, and again minus 1 and minus 1. Here, and draw this foundation. I just draw one foundation. I'll tell you, because when I edit everything, assign a spring and subdivide this shell, then simply I can replicate it for all those columns, so I don't need to draw them one by one. Now we need to draw the lift foundation. So to draw the lift foundation, first, if it's important for you, you need to draw the lift pit. And lift pit generally is 1.2 meters lower than the basement level. And you just need to bear in mind that always shell elements will be connected from center to center, so center of thickness to center of thickness of element. But if you want to show it on top, there is no kind of rigid zone for shell. So if you lower the shell to put the foundation in the right location, that means, for example, if the foundation for lift is say 800 millimeter, you want to lower it down and 400 millimeter, you actually increasing the height of the wall 400 millimeter. So you don't need to do that. You just need to draw it 1.2 meters lower and keep the shell there. It's accurate enough for your design. How we can do that? We don't have any grid lower than z-3, so we need to come here in edit grid data and add a new actually z level. So here is basement. Here we can put add, and for example mention lift base, and then this number would be minus 4.2, and then you just add it. So we have this one, and just press OK and OK here. Now you have it. If we go down, we can see minus 4.2. So we need to extend lift wall down to actually have the lift pit. So lift pit thickness could be different. Just to save the time, I'm using the same thickness of wall, but you can generally, because lift pit is a small component, if they want to pour everything 32 MPa for the foundation and a slab on ground, it's very hard for them to supply just a little bit concrete 40 MPa. So generally we consider lift pit wall thicker, but use the same 32 MPa or whatever is the grade of concrete for foundation. But it really back to the type of job, the accuracy is that tier 1, tier 2. If they are top builders, they don't mind. If they are normal builders, they maybe actually have a bit difficulty in supplying. So you need to see whom you are dealing with and what is the scale of the job to make the right decision about the thickness and grade of lift pit wall. So let's draw the lift pit wall. Just to save the time and ease of modeling, I'm using the same wall property as lift core wall. What I need to do, I need to come to the right plane to be able to see that. So currently I'm in this plane, so I'm coming forward to grid 4. Now I can see the wall. So what I need to do, I need to come here and select core wall 40 MPa and just draw it here. Right now I'm editing this, so I'm selecting all joints above with this element. I'm coming to this and I mention here that divided with intersection with selected objects, point objects. So I'm choosing these and apply, and that would be the same as I want. So I leave it here, then I'm moving forward. Now I'm drawing another shell element, so this is correct. So I'm drawing this one here, and then again select these joints with this shell and using the same command. So I have this one. Now I need to change XZ to YZ plane. Now I need to again move forward to reach to the lift core. Yep. So do the same. And just select this joint and apply this command and move. You can use quick frame, just need to ensure that this is correct. So you can come in front and then press here and again do the same, apply. Okay, so my lift pit wall is modeled now. Now if I come to the plane and move down, I can see the lift pit wall. Now I want to draw the lift pit wall foundation. Again, it's really back to the condition. Sometimes lift pit wall is bigger, sometimes if it's on the rock, sometimes they just draw vertical cut and have a lift pit wall completely confined between rocks. Sometimes they want to have drainage around to ensure there is no water seepage later into the lift pit. So we assume that we have a foundation a bit wider than lift. So I will consider, say, 500 millimeter each side wider, so plus 100 millimeter thickness, that would be 600 millimeter each side. You can simply come and draw a foundation here like this, because you already have these edges. Then you can extend it, so you can come here and then say edit area, and then you can expand it. I can mention how much it would be offset. So for this case, this would be 0.6 from each side. So when you do this, it's automatically offset to this size. So this is the lift pit foundation. We just forgot to change the material. So I'm coming here to shell area section and I'm choosing foundation 700 and apply. So sometimes I give you some different numbers when I'm setting an example, so just don't take it seriously. If I said, for example, sometimes the foundation is 800, it doesn't have to be 800. I'm just showing you guys how to prepare the model, or sometimes just to run the numbers to give you a better indication about what I mean.